Hey folks, how's it going? This is Mr. Moray coming to you with a optional enrichment due now for Course 1 CP. I'm making this due now because I've got a feeling that going forward we're going to really continue to reinforce function analysis. Alright, especially during this closure where I think that one of our ideas is that we want to continue to reinforce and build up the skills that we've talked about so far this year. I feel like one of the directions we are thinking about going in as Course 1 CP teachers is really continuing to emphasize analysis, because that's something we've talked about kind of since December. That is, not only we're hitting on it over and over, not only because it's important this year as we study different kinds of functions, but really it's going to be important throughout your high school career, because one of the common things in algebra is the study of functions, whether that be quadratic and absolute value and exponential and linear this year, or maybe square root and cube root functions next year, and maybe we'll talk about wave functions the year after, which represent sine, cosine, and tangent, and you'll know more what that means as you progress. But one of the common things is we want to understand, one, how do we analyze these things, and also we want to think about how do some functions compare to others. All right, so here's what I want us to do. Go ahead and take a look at this graph. This is the graph of a parabola on the right. I want you to take a moment to see whether you can find these 7 items. Okay, so what I want you to do, pause the video, using the graph, find these 7 items. All right, and then when you're ready, unpause, and I will show you how to go ahead and find them. Alrighty, so we'll start with the domain and the range. So the domain, now what we know is that the domain, and I kind of said this, it's kind of like, and I've said this a few times, hopefully, this is kind of like a trick question, right? So we can see that there's arrows on the end of the graph. All right, I'll show you what I mean. Got arrows here and arrows here, so we know it goes on forever. We know that, and I'm hopefully going to do a good job here. I'm kind of put on the spot. If I trace this with my pen, with that exception of that little squiggle mark, so you can imagine tracing over this with your pen. You never ever pick up that pen in the process of doing it. So what that tells you, to me, is that the function is continuous. Okay, and so as a result, you're going to have a domain of negative infinity to infinity. Okay, and remember what that symbolizes is that no matter what x you plug into this function, you will always be able to find a corresponding y or output value. Okay, what about range? So this is a function that points up, meaning it has a minimum. So the lowest y value you can ever find is 1. That's the minimum. And then because of the upwards pointing arrows, the maximum is infinity. Okay, the axis of symmetry here is x is equal to 3. And let me just grab a quick line here. Alrighty, and we can see it's an up and down line, so it's x equals, and it goes through 3, so it's x equals 3. I'll just get rid of that so we can see a little bit more carefully. The vertex has the coordinates 3, 1. You do need to give me the x and the y. It's this point right here. Okay, x-intercepts, interesting. So if you were in the Google Hangout, and I recommend if you're not, you take a look at the video from the Google Hangout and or the notes. One thing we talked about is that, look, there are some graphs that start above the x-axis like this one does and point up. And so as a result, this function will never touch the x-axis and there's no x-intercepts, and that is okay. Sometimes quadratic functions will have 2 x-intercepts, sometimes they'll have 1 x-intercept, and sometimes they'll have no x-intercepts, and that's okay. You just have to have a keen eye, and you got to look out and think about it logically. How many times is it touching the x-axis and where? And those are your x-intercepts. Okay, y-intercept, we can see it touching the y-axis here at 0, 7. All right, and last but not least, transformations from the parent function. So I'm just going to quickly erase this so I can see more carefully what's going on. So there is a little bit of a stretch that occurs, but we're not going to really focus on that. Let's focus on just the other transformation. So this is what the parent function looks like. Looks something like this. So, like I was saying, you can see that the function that we were given to begin with is a little bit wider than the parent function. See how it's a little bit wider? So there is likely a dilation, but it's unclear what the dilation is, so I'm going to leave that alone for now. But what we have is we have a translation, and if you want to know what it is, you choose a point. I'm going to choose the original vertex, and then you choose the corresponding point on the new graph, and you ask, how do I get from that original point to the new point? And the way you do it is to translate right 3 and up 1. All right. And so those are some key analysis items we need to know. All right. Hopefully you found this video to be helpful and you were able to get the right answers here for all of these analysis items. Again, this is stuff that's really, really important to know. If you're stuck on any of the definitions, I recommend you go back and look at the Google Doc. And if you look at the very, very top of your class's Google Doc, there's a link to the analysis notes. And on those notes is the definitions of everything you're going to need to know. So if any of these terms are unfamiliar, I really recommend you consult that. But analysis is going to be really important, not only this year, but throughout high school. So that's why for now, I'm going to keep hammering it home. All right. So again, thanks for doing this Do Now. Much appreciated. Keep up the good work, folks. And remember, you can do it. All right. Thanks again for watching. Feel free to like or subscribe so you can stay up to date on my newest videos. Don't forget to love math and have a wonderful day.